Understanding trigonometric ratios. So here we have a series to understand trigonometric ratios. I'm taking 9 to 10 communication questions here so that we get conversant with trigonometric ratios and later on we can apply them effectively to solve many different situations. It's such an important topic that having a good foundation is kind of important, right? So I don't want my students to get lost, and so let's really work on it and try to understand what trigonometric ratios are. Question number 1, when I'm starting with C, it means communication question, right? So those questions when you answer, don't forget to give explanation of your answer, because the marks is not really for the answer, it's for the explanation you are giving, okay? Remember that. Now, the question here is, how can you solve a right triangle given a side and an angle? So this is actually a very basic question which we are going to answer over and over again. So all this trigonometry is about this. That is, you are given different situations in which you can form a right triangle some way or the other, and once you can form a right triangle, they say, well, we give you a side and an angle, find the other things. Well, let's say we know this side and we know this angle, find the other things. Solve a right triangle, or rather say solve a triangle. What does that mean? So first thing you need to understand, solve a triangle means what? It means find all angles. That is what it means, and it means find all sides, side lengths, all side lengths and all angles of a triangle. That is what it means by saying solve a right triangle. I've introduced the word triangle, but if I say solve a triangle, it means the same thing, right? So just to start with and giving you concept, it makes my life simpler if I use a right triangle, correct? Soon we'll learn sine law, cosine law, and then we'll deal with all of the triangles. Don't worry about it. We'll be there soon. So imagine now we're working with right triangles. Now how to solve right triangle? That is the key issue for us. So what you have to do is look at the right triangle first. Now, and then think how. So basically what we know is about trigonometric ratios, what is sine, what is cosine, and what is tangent. So sine, you say sine is opposite over hypotenuse. That is sine. We write sine as sine of an angle. Let me give this a name A. Sine of an angle A is equals to opposite side over hypotenuse. Let me write like this. And let's say this is my opposite side and that is my hypotenuse, and this becomes my adjacent side. Adjacent side is between 90 degrees and the angle we are talking about. So this is what sine is when we're talking about trigonometric ratios, okay? Now, what is cosine? So we say cos is adjacent over hypotenuse. Adjacent over hypotenuse, and we write here as cos A equals to adjacent over hypotenuse. So that is my cosine. And the third term, which we'll use most of the time, is tan. Okay, so what is tan? So we say tan is opposite over adjacent. Let me squeeze in here, opposite over adjacent. Okay, so let me write separately. I had a lot of room, I just rushed. So we can say tan A is equals to opposite over adjacent. So these are three primary trigonometric ratios, and you'll soon learn about their reciprocals, which will be cosecant, secant, and cotangent of an angle, right? Now let's concentrate on the basic primary trigonometric ratios. How to solve a right triangle? Now these ratios help us to solve right triangle if we are given an angle and any one side. Now let us assume different scenarios, and let's say, well, this is my triangle which I need to solve, and in this triangle I'm given what? If you need to solve using sine, then the three things which you should know or you want to know will be these and these, kind of. These are the three things, right? So one of these. If you have angle, opposite side and hypotenuse, use sine. Very simple thing, right? If you have a situation like this where you know you are relating this with adjacent side and that, something like this, then use cosine, right? And if you have a situation in which you are dealing with angle, opposite side and adjacent side, then your solution is to use trigonometric ratio called tan, right? So this is how you have to think about it to solve a right triangle. So basically these are ratios, right? Because something is equal to something over something. Cross multiply and get your answer. That's it, right? So just a quick reminder here. You have to, given a problem, first sketch your diagram and try to form a right triangle. Once you have a right triangle, then you see which sides are opposite, adjacent and hypotenuse. And then figure out what is given to you. If amongst the given sides is the angle in opposite side and you need to find the hypotenuse, then you use sine. But if the given side is angle in opposite side and you need to find adjacent side, then use tan, correct? So that is how you have to figure out. That is what it is. And well, remember one more thing. There is a lot of flexibility as far as angle is concerned. Why? I don't want to complicate, but let me just give you an idea. This angle, if we know one angle, we actually know the third angle also. Because third angle is what? Total is 180. 180 minus 90 is 90. So this angle is actually 90 degrees minus angle A, right? So we effectively know the third angle. So let me cut my discussion to precisely one thing. That if hypotenuse is involved, then use sine or cosine, correct? And if hypotenuse is not involved, if it is the adjacent and opposite sides, then use tan. And that's kind of a clear line between what should you use and what you should not be using, correct? So if hypotenuse is involved, if it is given or if you have to find one, in that case use sine or cosine, otherwise use tangent. So most of the problems where we are saying we are so much distance away from something and the height we need to find, in those kinds of questions tan is your trigonometric ratio to be used, correct? But in this situation when we are talking about line of sight, right, how far the things are when you directly see, or a diagonal of a rectangle, right? So those are the things where hypotenuse is involved, and in all those examples use sine or cosine, correct? That should kind of help you out to at least begin with solving your problems, right? Question C1, communication question 1, if you do the right beginning, the end is going to be bright. Thank you and all the best.